nerves. What do you need to know? You need to know the number and the name and be able to identify them on this diagram right here, and their general function, whether sensory or motor. Let's start though with numbers, names, and visual identification. So first we should orient to what we're looking at here in this diagram. So we're looking at the brain kind of in an anterior / inferior position. So if you took the front of the brain and you tipped it up, excuse me, if you tipped it up a little bit, then you would see the brain stem down here. So actually here's the medulla, here's the pons, the big lump, and the midbrain's kind of hard to see. It's tucked in there. That's what we're looking at in this diagram, and all the cranial nerves are coming out of the brainstem in the anterior. So they're numbered top to bottom. They come in pairs. There's a right and a left. This is pair number 1, and they're written in Roman numerals. So remember that. And then here would be pair number 2. Then 3. I'm going to quit writing the numbers. 4, as we make our way down. 5. Note something about number 5. 5 here, and that would be written like this, a V for Roman numeral 5. It has 2 parts, and we'll talk about each part has a different function. So we'll talk about number 5 has lots of functions. So we'll get to that in a little bit. But notice that there's 2 little sprigs coming out there, 2 little portions of the nerve. So remember, it's not 2 separate nerves in the case of number 5. Now, then, to continue going on, we need to go to the middle. So you jump to the middle, and this is number 6. So for the most part, you go down, but you got to remember when to go to the middle. 6, you go to the middle, and then 7. Actually, 7 also has 2 parts. So take a note, there's a 2-parter here as well. Number 7, you can see it over here, the 2 little sprigs. Then we have number 8 right here. 9, 10, 11. 11 gets some contributions from the spinal cord as well. So it has a lot of roots there. And then you have to go to the middle again to get to 12. So the 2 times you go towards the middle here are 6 and 12. Okay, so those are the numbers. You also need to know the names for each of these 12 and the functions. So we're going to go over those in more detail. So this is a table from your book that presents the cranial nerves in excruciating detail, their function. Well, somewhat excruciating. Some of them are easy, like smell, olfaction. That's pretty straightforward. And then you'll notice nothing under these 2 columns. For now, for this video, just know sensory and somatic motor. For the most part, this is somatic sensory. So somatic sensory being the sensory information that you're consciously aware of. So this is somatic sensory. This already labeled somatic motor, so that would be voluntary motor. What we're not going to do in this video is parasympathetic motor. That's autonomic. We will get to that when we get to chapter 18, so disregard this for now. Otherwise, you'll notice that there is, in some of these columns, a lot of detail, like this one, for instance. I am going to go through each of the cranial nerves right now in this video and tell you how much detail do you need to know. In some cases, it's not this much detail. So this is your guide to what you do need to know. Let's go through it. Number 1, olfactory. Olfactory is smell. Oops, I can spell it. Smell, right? That's it. That's the function. You'll notice here that these diagrams are very helpful in that they give you just a visual picture of what the function of each of these nerves are. I will not ask you on an exam to identify these nerves in these diagrams that I'm about to show you. This is the diagram right here that you need to know for visual identification. Okay, so notice here you have a bunch of these little nerve roots for the olfactory nerve. and they all go through the cribriform plate, which hopefully you remember. The cribriform plate is on the ethmoid bone, and that is an eye, I assure you. The ethmoid bone, all those teeny little holes that you should have seen in lab, and on a plastic skull, they can be tricky, but usually they add them in on the copy, the mold. So you should have been able to see a bunch of tiny little holes surrounding what is not well illustrated here, but the crista galla is in the middle of that cribriform plate. So that's just a little orientation where you're at. So whenever I think of ethmoid bone, I think of smell because of the olfactory nerve, but also, hopefully you remember, ethmoid bone forms these concha, the superior and the middle concha in your nasal cavity, and also part of your nasal septum, which is not shown here. So I always think of ethmoid bone, I think of smell and nose for a lot of those reasons. Okay, so the next nerve would be number 2, optic nerve, vision, pretty straightforward. There's your eyeballs. Notice they cross here, and hopefully you recall that stuff in your right visual field will end up on the left side of the brain, and then vice versa, stuff in your left visual field is going to be processed by the right side of your brain. So you can see right there, they cross over before they get inside the brainstem. Most of these other nerves cross inside the brainstem, so you're not going to see this thing called the optic chiasm. It's just where the fibers cross from left to right. So this is an example of this word I told you to remember. And I'll bring it up a couple more times in this unit, decussate. That's where the fibers cross from left to right. Okay. Keep going through. Number 3, ocular motor. Ocular motor, oculo refers to eye. Motor, of course, motor. These move most of your eye muscles. This particular nerve innervates most of your eye muscles. So if you look at an eyeball straight on, like here's my iris, there's my eyeball. These muscles are, first of all, you have 4 that go in the 4 basic directions. These are rectus muscles, superior rectus, medial rectus. So we're going to say this is our nose right here. Here, I'll draw a nose. That's a nose. And then you've got lateral rectus and inferior rectus. So they just move the eye up, down, side to side. And ocular motor does all of those except this one off to the side, lateral rectus. And we'll get to that nerve in just a little bit, which nerve innervates that particular muscle. The other types of muscle that you see around the eye, you've got 2 muscles, oblique muscles. You've got one that's called a superior oblique, kind of comes around like this, and you've got an inferior oblique that comes around like this. Those oblique muscles will rotate your eye. So they would rotate it like, if you can imagine this muscle pulling, they're going to rotate the eye in these directions like this. Your eye can do a little bit of weird rotation like that. These muscles, one of them, the superior oblique, is not innervated by ocular motor. It's innervated by this nerve, trochlear. So this cranial nerve number 4 only has one muscle. That's all that it does. And that one muscle is, again, the superior oblique muscle of the eye. So that one right there. And the name, if this is helpful for you, I won't ask this on an exam, but where the name comes from is the superior oblique is right here. You can see the nerve going to this muscle right here that kind of turns a corner right there. That corner is formed by this little sling. It's just a little like ligament right there. The muscle goes through that, kind of like a pulley. And that thing, that little ligament that the muscle strings through is called a trochlea. And a trochlea is very similar to what you see on your elbow joint. So the humerus, you may remember the distal end of the humerus has that, I think it looks like a spool kind of like a rounded area there, the trochlea of the humerus. And you may recall that the ulna, the olecranon process and the trochlear notch of the ulna fit around that trochlea of the humerus. So it spins around the trochlea. That's this kind of same pulley or idea that you see here. That's where it gets its name. The trochlear nerve is from having this little sling-like pulley, which is somewhat similar to the way that your ulna rotates around your distal humerus or your trochlea of your humerus. Trigeminal nerve. So this is number 5, and maybe you recall right here, I pointed out trigeminal, number 5, has 2 little parts to it. Actually, a big part and a little part. So this nerve does a lot of things. Main job is somatic sensory. So that would be sensory that you're consciously aware of to your face. Fine if you just know that. There's actually 3 major portions of it. This here is the beginning of your trigeminal nerve right here. And then, notice that. That's a ganglia. You have a big fat sensory ganglion for number 5 right there. And then it has 3 major parts that innervate the top part of your face. And then you've got a second part that goes to about your mid-face area and your top teeth. And then finally, you've got a third part of it that innervates the bottom part of your face and your lower teeth. So you can see that diagrammed up here as well. And we call those divisions, they have names, but I'm fine if you just know. We call them V1, V2, V3. The V is actually Roman numeral 5. But by convention, I always hear them called V1, V2, V3. This is a huge nerve and a huge ganglia because your face and your teeth are incredibly sensitive. You might recall, hopefully, I'm going to bounce back really quick. I have to go back a little ways because there's a lot of brain stuff. Boom, here. You remember somatotopy, body map. And here's sensory over here on this side. So this is, you can barely read it there, but this is primary somatosensory cortex. So the part of your brain that processes somatic touch that you're aware of. And it's located in the post-central gyrus of, hope you remember, parietal lobe. Okay, you remember the body map is kind of distorted. It has weird proportions. So some parts of your body, like your hip and your thighs and your trunk here, are really small because they're not very sensitive. But by contrast, your face and your teeth have this huge area because they're incredibly sensitive. Well, that is reflected in the size of the trigeminal nerve. It's a big, big nerve. But that's not the only thing trigeminal does. So it does, I already listed it and erased it, but somatosensory to your face. The other major job that it has is motor to muscles. By the way, 2 M's is an abbreviation for muscles, plural, of mastication. Your chewing muscles. So, hopefully you remember the 2 major chewing muscles that we learned. There's a few chewing muscles, but the 2 major ones that we already learned were the masseter muscle, which would be right here. And the other major one is temporalis, which would be right about here. So trigeminal provides those 2 major functions. And I want you to know that somatosensory to the face also includes, I mentioned lower teeth. I do want to mention one other thing because it's interesting. Tongue. It also does somatic sensory to the tongue. So that would mean not taste to the tongue because that's a special sense. Somatosensory is just touch. So somatosensory to the tongue means like if you bit your tongue or if you burned your tongue like on a hot drink, That's somatic sensory. That's not taste. So there's actually two different nerves that carry those two different types of sensory information. And I'll get to taste later on when I get to other cranial nerves. So trigeminal, big nerve. It's doing a lot of things. Okay, abducens. Abducens is providing innervation for one muscle that moves your eye, and that is lateral rectus muscle. So just a little bit ago, I talked about the other nerves that supply innervation to the other muscles. So the other muscles being like superior rectus is up here, medial rectus, we can see kind of back there, inferior rectus, so all the straight ones that just move your eye, in up, down, right, left. And then the muscles that rotate your eye. Remember, there was the superior oblique that zips around here. That's cranial nerve number 4. And then, oh, I forgot, inferior rectus. That's also done by, all the blue ones are done by cranial nerve number 3, ocular motor. And then finally, we've got this lateral rectus that they've cut away a little bit. You can see the nerve right there. That is cranial nerve number 6. So these tiny muscles of your eye are innervated by 3 different cranial nerves. Okay, facial nerve, our next one down here. Facial nerve number 7. Facial nerve's primary is motor to muscles. Again, 2 M's means muscles, plural, of facial expression. So not chewing muscles. Chewing muscles is 5. Facial nerve does these muscles like orbicularis oculi, your 2 zygomatic muscles, orbicularis oris, etc. All of those muscles, and buccinator, even though it's kind of not really for facial expression, but nonetheless, it's included in this group. Oh, and frontalis up there. All of those little thin muscles that we learned that control your facial expression. That's facial's primary job. So this often gets confused, just FYI. Students get confused of which one does sensory and which one does motor. Facial does motor to the face. Sensory to the face is 5, the big trigeminal nerve. But facial also has one other random job. This feels very random. It does, and I can barely see it there. Let me erase the rest of this. You can see there's a couple fibers. They show, they show a couple fibers here going to the tongue. It does taste to the anterior 2/3 of the tongue. Tongue is kind of ridiculous. And then it gets lots of innervation. So, special sense to the anterior 2/3 of the tongue. And just to remind you, the somatic sensory to the anterior 2/3 of the tongue is facial nerve. Trigeminal. If I haven't confused you enough, sorry. Somatosensory to the anterior 2/3 of the tongue is cranial nerve number 5. So 2 different types of sensory, 2 different nerves. And just to make it confusing, for the most part, facial does motor function to the face, except for this one sensory job. And for the most part, 5 does somatosensory to the face and the tongue, except it also does motor to mastication muscles. Number 8, vestibular cochlear. Vestibular cochlear does vestibular. You should have learned this in lab, a little bit about what's going on in the inner ear. So vestibular refers to this organ right here. It's for, well, it's usually said to be balance. There's a few systems in your body that control balance. But this vestibular system, it will provide you with information about the position of your head. So is like your head really flexed forward? Is it flexed backward? Is it tilted? Is it like laterally flexed towards your ear? Is it rotated? So that's what the vestibular system does, is information about the position of your head. And then cochlear refers to this organ right here, the cochlea, which cochlea means like shell. It looks like a shell of a like snail or something like that. That refers to auditory or hearing. That's the organ of hearing. So cranial nerve number 8 provides, this is special sensory in both cases, special sensory of balance, or I'm fine with balance if you put that on an exam, or position of the head, and auditory or sound. Then number 9. Number 9, honestly, it does a lot of things, and most of what I think is interesting is what it does for autonomics, which we're not going to talk about right now. We'll just talk about the somatic stuff that it does. Glossopharyngeal does, this is all I want you to know for now, taste and somatosensory to the posterior 1/3 of the tongue. So, previously we just learned that 5 and 7 do taste and somatosensory to the anterior 2/3 of the tongue. 9 covers both types of sensory in the posterior 1/3 of the tongue. Vagus, 10. I'm not going to say much about vagus now because vagus is an autonomic nerve. So this is unconscious motor, which again we'll talk about later when we get to chapter 18. But vagus is, it's actually, its name comes from the word vagabond. And vagabond means like somebody who is transient. They don't have a home. They wander the world. That's what vagabond means. And they named vagus that because vagus starts way up here in the brainstem, and you can see it wanders all the way down, as far down as your intestines, and it innervates a ton of organs in your thorax and your abdomen. And again, we'll come back to vagus when we get to autonomics, so it's fine if you just know that now. 10 does a lot of internal organs. Okay, 11. 11 we call accessory. I've also heard it called spinal accessory, as you may or may not recall, but I'll bounce back and remind you. It gets some contributions, you can see, from the spinal cord below, because that'd be about the foramen magnum right there. So everything above is medulla oblongata, the very inferior part of the brainstem, and everything down here is spinal cord. We're getting into spinal nerves. Anyway. Okay, so again, spinal accessory. If that's helpful, I will not ask you on an exam, but might be helpful for you to remember how to visually identify it. And that is also helps remind me that if it's got spinal contributions, it actually does muscles that are not in the head. You notice that, except for vagus really, all these nerves do stuff in the head. Well, spinal accessory does stuff that attaches to the head, but it's also really more of a neck muscle. So 2 muscles, motor to 2 particular neck muscles. This one, which I hope everyone knows what that is. I'll remind you. Now it's sternocleidomastoid muscle, big muscle of the neck. The other major muscle that accessory does is this one, which we're kind of at a weird angle, so that might be hard to see, but that is trapezius. Oops, I just erased the words. Well, anyway, that's trapezius muscle. So that's what spinal accessory does, or accessory. Number 11. Sternocleidomastoid and trapezius. Okay, that leaves us with our final nerve. Finally, on this long list, hypoglossal. Hypoglossal does motor to your tongue muscles. You actually have a lot of tongue muscles that do complicated things, which we're not learning all those tongue muscles in this class. We don't have time. You can see, actually, if you just look here, look at all these crazy muscles that anchor your tongue and move it around. And it's pretty big nerve because these muscles have really fine motor control because, of course, these are the muscles you use for speech. Some of the muscles, you also have muscles down here to control your larynx and muscles that control your lips. But this is like a major part of speech, right? And hopefully you remember, in the brain, where is motor speech coming from? Well, the motor speech area, also called Broca's. So Broca's, or motor speech area, it's part of your frontal lobe. It sends somatic motor, so voluntary motor messages via this hypoglossal nerve and tells your tongue muscles what to do so you can talk. Also eat. Tongue is important to eating as well. So hopefully, perhaps this may help you remember this. You notice this term gloss? Gloss or glosso. You've actually seen it before. Cranial nerve number 9, glossopharyngeal. This refers to language, this word. And if you've ever heard this term, glossary, so your textbook, lots of textbooks have glossaries. It's like a list of definitions, like a dictionary in the back of the book. Lots of textbooks. That's where glosso refers to language. So hypoglossal, think, really anytime you see gloss, think tongue. So hypoglossal, muscles of the tongue. And then the other glosso word we had here was glossopharyngeal, and it does somatic, sensory, and taste to the posterior 1/3 of the tongue. So again, glosso referring to tongue, not necessarily always to speech though. 9 doesn't do anything with speech, but 12 does. So I always do this review of the tongue for some reason, because the tongue is crazy to me. It gets so many different nerves. So really quick review of the tongue. 5, trigeminal, does somatosensory, so touch, to the anterior 2/3 of your tongue. And then we have facial, 7, it does taste to the anterior 2/3 of the tongue. Then we have 9, glossopharyngeal. It does both, I'm going to abbreviate, somatosensory and taste to the remaining part of the tongue. So that would be the posterior 1/3. And then finally, we've got 12. 12 does motor. It's the only one that does motor to the tongue muscles, to all of them. So yeah, the tongue is just kind of crazy. There you go. Those are the cranial nerves.